the detection of alien galactic worlds, is always accompanied by an exciting question. Are we alone? Accordingly, the exploration of newly discovered exoplanets is also always subject to the question of whether the celestial body is possibly habitable or possibly even already inhabited, while mankind has yet to prove the first extraterrestrial signs of life. Some unusual signals from space are causing wonderment in the ranks of researchers. What makes the so-called fast radio burst so puzzling? And which immense problem of modern space travel we must not disregard? You'll find out now. Want to learn more about the exciting spectacles and discoveries in the cosmos on a regular basis? Then remember to subscribe to the Science Signal and click on the bell to stay up to date from now on. By giving us a thumbs up, you're showing us that we can keep you engaged with the content of our videos. Mysterious fast radio bursts. The year is 2001 and the Parkes Radio telescope in Australia receives an unusual signal from space. However, it was not until 5 years later that the experts became aware of the extraordinary phenomenon that had been recorded only when they looked at the corresponding archive data again. Today, we know that this was the first detected fast radio burst in history. Since then, there have been many of these unique emissions, but what are they in detail? A fast radio burst is a one-time or repetitive burst in the field of radio radiation which usually lasts only a few milliseconds. While the sources of the emissions identified to date were still outside our galactic home, in April 2020, experts succeeded for the first time in detecting the corresponding outbursts within the Milky Way as well. Shortly after the first radio burst was identified, experts were faced with a central question. What is the origin of these unusual phenomena? For example, pulsars, or in other words, rapidly rotating neutron stars, are also known to emit immense radiation. However, these are recurring phenomena. Most fast radio bursts are one-time events. The only exceptions are the so-called repeaters, but compared to their singly occurring counterparts, they have been observed much more rarely. No less mysterious appears the fact that there were no known astronomical sources at the locations of the identified emissions. In order to trace the positions of the outbursts, experts examined the so-called dispersion. In the technical world, this term refers to the dependence of a physical quantity on the frequency of a wave. In the case of the fast radio bursts, their distance could be determined because free electrons slow down the signal. Here, it's important to mention that the free electrons in the interstellar matter could cause only about 5% of the detected dispersion. The rest must, therefore, have an extragalactic background. The distance of the radio flashes detected so far was between 1.7 and 3.3 gigapars. The mystery of source. In order to explain the origins of these short-lived emissions, experts have put forward various theories in recent years. Many are based on the assumption that the fast radio bursts are caused by neutron star-based processes. They could be an extremely strong variant of soft gamma repeater bursts. Other researchers suspect that the emissions are among the hitherto unknown characteristics of extragalactic pulsars. However, neutron star mergers, supernova explosions, and the collapse of a massive neutron star into a black hole have also been discussed as possible backgrounds for these unorthodox radiation bursts. Far away from these neutron star-based thesis, theoretical eruptions of a flare star, the evaporation of a black hole, and the fusion of white dwarfs have also been proposed, while the previously observed fast radio bursts were still irregular events. Researchers' knowledge has recently been significantly expanded. This is because the experts recently discovered the periodicity of a fast radio burst for the first time. Namely, they observe that emissions are subject to a recurring 16-day cycle. However, the hundreds of bursts detected a few months ago in an incredibly short period of time easily dwarfs all fast radio bursts recorded until then. 1,652 emissions in 47 days. What extended the detection of fast radio bursts exponentially is the Fast Radio Telescope in southwest China. As the world's largest instrument of its kind, FAST has a gigantic main mirror, which has a diameter of 1,500 feet that probes different celestial regions for radiated radio waves. The exciting thing, in a period of just 47 days, the radio telescope recorded a total of 1,652 fast radio bursts. Even more exciting, it appears that all of these emissions had one and the same source. Even before this fascinating discovery, the source of the signals, which goes by the scientific name FRB 121102, had repeatedly become the focus of astronomical interest. In detail, experts succeeded in locating the origin of the emissions in a dwarf galaxy 3 billion light-years away from us. It quickly became clear that the repeaters generated here are subject to regular intervals. Thus, the preceding analyses showed that the corresponding cycle covers 157 days. This cycle could be divided into a 67-day inactive phase and a 90-day active period. Already at that time, the scientists observed how the source once emitted 20 pulses in one day, and another time 12 emissions in just 2 hours. The fast radio burst source again experienced by far its greatest period of activity in 2019 when FAST identified more than 600 bursts there between August and October. The peak of these never-ending waves of emission was 1 hour of a whopping 122 fast radio bursts. The energy emitted during this 47-day period of activity was equivalent to nearly 4% of the total energy of a magnetar. Furthermore, scientists recognized during the evaluations that the energy distribution of the radio bursts is biodal. In simple terms, this means that the weaker emissions occurred virtually randomly while high-energy bursts occurred with relatively high consistency. Although the origin of these phenomena is still a cosmic mystery, researchers have succeeded in narrowing down the theoretical sources to some extent. Thus, the unusual characteristics of the phenomena shake the previously held notion that the outbursts are produced by a single compact object. Those who had hoped that the recorded results would point to an artificial background mechanism may now be somewhat disillusioned. The high outburst rate argues against extraterrestrial actors being involved. In the future, the high rates at which the radio flashes come along should help make the in-depth analysis of these equally exciting and mysterious events even more insightful. Galactic garbage collection. To conclude today's post, we'd like to share with you a topic that is fading into the background a bit in light of the groundbreaking discoveries and research missions of the experts. The increasing pollution of space. The debris that now circles our blue home planet consists of millions of objects. The corresponding pieces of space debris range in size from an ounce to several tons. As the ESA announced some time ago, 6 decades of space travel and more than 5,000 rocket launches were ultimately accompanied by 8,500 tons of space debris. This includes 3,000 satellites alone that have long since ceased to be active, but worn-out rocket stages and tools that were lost during maintenance and repair missions are also among the unsightly companions of our Earth. The thousands and thousands of pieces of waste in space also harbor a danger that should not be underestimated. If a satellite collides with a piece of scrap that is just a few inches in size, a full-blown cloud of debris can be formed. If the corresponding chunks now enter the Earth's atmosphere, they become dangerous projectiles. Even a half-in piece hurtling towards the Earth at a speed of 25,000 miles per hour has the same destructive power as an exploding hand grenade. But apart from this serious danger, the progressive pollution of space comes with major problems. The thousands and thousands of pieces of scrap metal make operating in space more and more complicated. In fact, the ISS has to perform several evasive maneuvers every year to avoid colliding with the junk pieces flying around. As it is known that more and more satellites are leaving our blue home planet, the associated complications will continue to increase in the future. To counter this negative development, ESA is now planning to carry out a truly ambitious project, the first cosmic garbage collection in history. However, before a large-scale cleanup of the cosmos can be carried out, the use of Clear Space One must first be tested as part of a trial run. According to the experts' plans, the galactic waste collector is to go into space in 2025 to collect the upper stage of a Vega rocket. The cleanup work is to be accomplished with the probe's 4 gripper arms. Once Clear Space One has packed the space debris at an altitude of over 400 m, it will plummet into Earth's atmosphere along with it, where both objects are expected to burn up together. Future cleanup missions could then be mastered by special tow probes that will be used multiple times. It's your turn. What do you think about the ominous fast radio bursts and the massive burst wave that experts observed a few months ago? Just drop us your thoughts, feedback, and suggestions below in the comments. Still in the mood for exciting contributions on the topic of outer space? Then take a look at the other videos on our channel which we have linked for you in the credits. Thanks for your interest. Take care and we'll see you next time.